Hi friends. So let us continue our chapter set theory. Hope you have revised a bit after the first class. Then today we will develop some confidence in understanding the very basic definitions of set theory, such as representation of set in the roster form, representation of set in the set builder of notation. We have to understand it. Once they're given set builder notation, how to write the elements of the set builder notation, or if they're given roster form and ask us to convert it into the, let us say, set builder form, we should be in a position to do it. For that, we have to understand again this definition a very bit thoroughly. So let us start now. First of all, yesterday what we said about the set. Set is collection of objects, numbers, or any kind of articles. This forms a group. Only thing is we have to remember very clearly that the elements of a set must follow a definite rule. We cannot keep elements inside a set which are not connected to each other. They must bear an equation. They all must have a kind of relationship among themselves. If you say a set of even numbers, it will start with, let us say, 2, 4, 6. So if I see the continuity of these numbers, I can predict the subsequent numbers. So that is a definition of a set. I cannot just like that keep anything inside a bracket and say that this is the set. No, we should not do that. A set must contain only elements which follow a definite rule. This is the definition of set. Yesterday we have understood this. Today we are going further in defining some more properties of these sets. So first of all, let us see a set is represented by means of a flower brackets. Two flower brackets, one is the starting, another is ending. Between these two flower brackets, we will keep the elements. Sometimes we call these elements as members, objects. Okay, so the words will change. They're all synonymous words. You can use anything, members of a set, or numbers of a set, or objects of a set, anything we can use. But flower bracket is compulsory. We should not use any other bracket. Set should be represented by only flower brackets. Next point is, once I start writing the elements inside the set, I must put comma after end of each element. I should not write them together. Yesterday, I remember having said this. So once again, I'm repeating, we should not write the numbers without commas. Commas are essential. So let us go to the whiteboard and start understanding these properties thoroughly. And our main aim of the today's class is to get confidence in writing between roster form and the set builder form. Whatever anything they ask, let us say they give roster form, convert it into set builder form. We have to do it. So that confidence today I'll give you. So let us go to the whiteboard. So we are supposed to now today understand these properties thoroughly. Very, very important. So that's why today we'll focus clearly on these fundamental aspects. Okay. Yeah. Now I'll write here now. Color I'll change. Yesterday put red color. Today we'll go to blue color. Yeah. So today what we do now, we will understand the properties. Properties of sets. Properties of sets means definition already we have given. Set is collection of objects. This is known very clearly to us now. but condition is objects defined by characteristic. We cannot put simply anything inside. This is a very important definition, first one. Second one, flower brackets are to be used. Do not change any other brackets, because if I change, let us say, square bracket, it can go to the definition of matrix. So we should not use simply brackets the way we wish. If I use small brackets, it will come as an interval. So there is a specific definition for each of the brackets. We should only, these particular brackets are defined for the set theory. What are they? They look like this, that's all. So next one is what? Elements are entered with commas. Okay. So how do we enter now? 1, 2, 3, like this. You can call these elements, as I told you, members, or what you call items. You can call members. You can call any words you can use. But what prominently used are elements. Elements word is better. Next, another important property of this set theory is we have told here that these elements should follow a specific rule. Elements without having connectivity, without having any set rule, cannot be entered. Cannot be entered. Suppose 1, 2, 3. After that, I wanted to write, let us say, root of 5 or root 6, root 7. Not correct. Because I have to follow a rule. I should be in a position to do some mathematical operations later. So if I start writing down here some unconnected numbers, which are not defined by any rule, then problem will come. So that is why we are supposed to follow a particular rule and then enter the elements. Now, let us understand certain nomenclatures. For example, n. N is known to you as set of natural numbers. Natural numbers. Already you know what are they. 1 onwards, it will start. It will go up to infinity. Okay. Next, if I write z, this you know, set of integers. Then if I write q here, set of rational numbers. Set of rational numbers. Rational numbers, they will be in the form of p by q, where p comma q are integers and q is not equal to 0. Then q dash is called as set of irrational. Set of irrational numbers. For example, irrational numbers are what? Root 2, root 3, root 5, etc. These are all irrational numbers. Now, real numbers are nothing but the union of these two. Rational numbers and irrational numbers, if you write together, you will be getting the set of real numbers. Set of real numbers. See, in the set of real numbers, rational numbers, we defined p comma q are integers. So if I write 2, for example, 2 is an integer. 2 is also a rational number because in the denominator 2 by 1, if you write, it will become a rational number. So rational numbers contain integers also. That is why if I write here q union q dash, it is enough here. That will show that it is a set of real numbers. All rational numbers and all irrational numbers together, if you write, it is called R. So that means, next page will go. R must be For example, if I write here 1 by 2, 1 by 3, root 2, root of 5 like this. So if I write like this is called as set of real numbers. Okay. Now, representation of sets when we are representing, when we are defining, yesterday I was telling there are two methods, mainly roster form. Another is called set builder form. Today, we will focus on them thoroughly. Today's main topic is this only. We should not have any doubt at the end. So now representation of a set. The representation of a set. I am having, there are actually three, but two are prominently defined. First one is called semantic form. First one is called what? Semantic. Second one is called roster. Third one is called set builder. So a set is represented by means of three. So what is first semantic? Let us define this. Semantic form is a statement is given. A statement is given. Like for example, A is equal to set of positive integers up to 20. Set of positive integers up to 20. So what does it mean? I can say that A is equal to positive integers 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So this is the definition of the set. See, now already set has come. How it has come? By seeing the previous statement. If you see, in the statement form they gave, semantic form they gave, positive integers up to 20. Is it up to 20 or less than 20? Up to 20. So we can write 20 also. Next, in the roster form. In the roster form, directly numbers are visible. There won't be any statement or anything. You can derive the statement by seeing the numbers. So let us say I'm having here 1, 3, 5 like this to infinity. So what is the rule here followed? All odd numbers we have taken. All odd numbers. So this is called, let us say B is equal to set of odd integers. Positive integers. These are all called what? Positive. Set of all odd positive integers. Okay. So next, so in the roster form, numbers are already defined given here. From this you can conclude, or you can write the next predicted number. No problem. Then third one is called as set builder. In the set builder form, they will straight away start with the flower bracket. This is the slight difference between the semantic form and the set builder form. In this, flower bracket will start set of all x, one colon will be there. This is called such that. You can use even side line bracket also, that is also such that. But this is x, set of all x such that x is even. X belongs to n. Okay, x belongs to n. This is definition, let us say we have got like this. Then this set builder form you can define by seeing this. X is even, they said, x belongs to n, they said. So start from 2, 4, 6 like this. Okay, so by seeing the definitions thoroughly, we should be in a position to write the builder form or roster form or statement. In any way, let them define the set. We have to write the elements. Sometimes they'll give element and ask us to write the formula behind it. We can easily do that. By seeing some small sums we can do and understand it. Yeah. Now let us say I am having one statement sum. Here. Here I have given A is equal to set of all x such that x is a natural number. X is a natural number which divides 42. X is a natural number which divides 42. So what we can write down here? This is the statement. This is called set builder form. Please understand that this is having a flower bracket. So inside that they are given x set of all x such that x is a natural number which divides 42. So all we can write down here. 2 will divide 42. 1 also will divide 42 times. 1, 2, then 3 will divide. 4 will not divide, no, 4 ones are 4 doesn't divide. 5 will not divide, 6 will divide. 7 will divide. 6 sevens are 42, remember. Then 8 doesn't divide. 9, 10, 11, 12, 13, 14, 15, 16, 17, 19, 18, 19, 21 will divide. Okay. 23, nothing will divide further. So straight away you can write down 42. So these are all the numbers, natural numbers, which divide 42. 42 will also divide 42. See next one. B is equal to set of all x such that x is a oval. X is a oval in English alphabet. This is the set builder form. You easily can tell me A, E, I, O, U. These are all the ovals. So X is oval in English alphabet. Set builder form they have given here. So they asked us to write the elements, we have written. If they had given this A, E, I, O, U and asked us to write the set builder form for this, you have to write the top one. X is a oval. Okay. Next, another one, let us see. Set of all x such that x is an odd natural number. So, sorry, x is an odd natural number. So odd natural numbers, you can easily write down one by one. You can write down. What we can write down here? 1, 3, 5, 7, etc. Infinity also you can go ahead. Okay, no? X is an odd number. That's all. Then, so from set builder form, we are able to write the elements clearly, is it not? Now, next one, let us see here. They have given one more sum. Write the set. Write the set. What is it they have given here? X is a don't forget these two dots. X is a positive integer. X is a positive integer and x square is less than 40. See the definition here. So we have to take positive integers, means starting from 1, and should be square of that number should be less than 40. So positive integer start with 1. 1 square is always 1. 2 square is 4. 3 square is 9. 4 square is 16. See, the condition is less than 40 should come. 4 square is 16. 5 square is 25. 36. Here it will stop. 1, 2, 3, 4, 5, 6. So from this statement, we could build the set. Okay. See another one now. Write the set. Now they have given A is equal to 1, 4, 9, 16, 25, dot, dot, dot. This is what? This is called roster form. Now we have to write set builder form for this. Right? Set builder form. So what we'll write here? You observe now here. 1 square 1, 2 square 4, 3 square 9, 4 square 6. That means each number in the natural set, they are squared now. So you can easily write set of all x such that x belong to x is equal to n square and comma n belongs to capital N. Is it matching or not? You check. You said x value, when x is value is means here, top here 1. Suppose n square, n is equal to, first you put 1. 1 square is equal to 1. N is equal to next to 2. 2 square is equal to 4. 3 square is equal to 9. 4 square is equal to 16. 5 square is equal to 25. So this is the answer. This is called a set builder form. Is set builder form. So by seeing this definition, we are in a position to clearly understand. That means again and again I'm repeating, whatever elements present in between the flower brackets, they follow a characteristic. What is the characteristic here? N square. Here x square is less than 40 is characteristic. They're all positive integers, x square less than 40. Here x is equal to n square, n belongs to n. N is set of natural numbers. Okay. So this is very important. Next one is called, let us say, x is an integer. X is an integer. X is an integer. I will write clearly here. Set of all x such that x is an integer and x square minus 9 is equal to 0. Close the bracket. So here x square minus 9 is equal to 0 means x square minus 9 is equal to 0. X square is equal to 9. So x is equal to root of 9 plus or minus 3. So now what is our answer? A is equal to minus 3 comma plus 3. This is the answer. This equation we should solve and then write the values here. These are integers. What is our next one? Set of all x such that x is a letter of word principal. So what does it mean? Close the bracket here. We are supposed to write here in the roster form now. P we can write, then R one more letter, then I one more letter, N we can write, C you can write. Again I came, already I is present here, don't write. P, again P is there, repeated not required. So next A write down, L write down. Close the bracket. So now see, X is a letter of word principal. So that means our set is now having some letters. These letters must be found in the word principal. They are found. P belongs to principal. R belongs to principal. I is also there in the principal. So these are the letters which defined the above statement clearly. Now one important point again here I'm telling you. Order of these letters doesn't matter. You can start with L, A, C, I, N, P, R. Or P, I, N, C, no problem. Principal that letters when you're writing inside, order doesn't matter. Repeated words can be deleted, letters can be deleted, not required. 2 times P even if you write, when we are counting it in the cardinal numbers, it should be taken as only 1. Okay. Now, let us define 2 important things. One is called as empty set. Empty set then equal sets. Two are there, two words. I will define these two now. First, what is meant by empty set? As the name implies, set should be empty. Correct? Meaning is correct. But what is the clear-cut understanding of this? For example, I'll write empty set here meaning. Yeah. Let us say I am having A is equal to set of all x such that x square is equal to 4 and x is odd. I write here x square minus 4 is equal to 0, comma, x is odd. This symbol is minus, okay? There is an equation, x square minus 4 is equal to 0. X is odd. Is it an empty set or not? We'll check now. X square is equal to x square minus 4 is equal to 0. Is equal to 0. X square is equal to 4. X is equal to root of 4, which means plus or minus 2. So our set will be what? Minus 2 comma 2, strictly speaking. But what they are telling, x should be odd, they are telling. Do you get odd numbers? We don't get. So therefore, A cannot be odd set. Therefore, A is an empty set. So we should not write A is equal to minus 2 comma 2. We have a set minus 2 comma 2. Is it fitting to the definition of A? No. Why? Because A, they said it should be odd. So there is no odd value for us, because once you take in the square root, 4 resulted in two integers, minus 2 comma 2, which are nothing but even numbers, negative even, positive even. So therefore, our definition doesn't fit here and A becomes empty set. Followed? So now, therefore, empty set now we can represent like this without any element present here. Sometimes this is called as void or sometimes null. Okay, it is also represented in this form, null set phi. Represented as this symbol, phi symbol. So null set is a very important definition. Keep in the mind, which will be useful now. Next, equal sets. See, whenever we are having two sets, let us say A is equal to 1, 2, 3. B is equal to 3, 2, 1. These two sets are said to be equal if they have identical elements and number of elements should be same. So in this case, you see number of elements Na is 3, Nb 3. Elements are, even though order is changed in the B, still all are 1, 2, 3 only. Okay. In this case, Na is equal to 3 and B is equal to 3. Elements are also matching. Therefore, A and B are equal sets. A is equal to B. If elements are not same, then they are unequal. Suppose A is equal to A, B, C. B is equal to D, B, C. A is not equal to B. Even though Na and Nb are same, but A is not equal to B. In this case, because elements are not same. Elements are not same. Now, another important thing I'll tell you, subset. Subset is very simple to understand. 1, 2, 3, you put A is equal to, let us say you are having another big set, 1, 2, 3, 4, up to 10. So your first set A containing only 3 elements, B containing 10 elements. Definitely A is not equal to B, but elements of A are present in B. Elements of A are present in B. Therefore, A is a subset of B. So we should write symbol like this. A is contained in B. So sometimes B is called superset. Superset means it contained all this. All your elements of A are present in this. Even if one element is missing, let us say here in the place of 1, 2, 3, 11 I have written, then not. All elements should be present in the other set, then only. Now, is B a subset of A? No. B is not subset of A, but A is subset of A. B, sorry. A is the subset of B. B is not subset of A here. If A and B are having identical elements, if A is equal to 1, 2, 3, B is also equal to 1, 2, 3, then A is a subset of B, B is also a subset of A. This is correct. In the previous case, B is containing more elements, therefore B cannot be a subset of A, but A can be a subset of B there. Okay. So friends, I will conclude here. Please revise this entire thing again along with the first class. And then tomorrow we will go to some mathematical operations on set theory and some Venn diagrams, other things we'll discuss, which are all again based on your 11th standard book only. I'm not changing anything. So please go through that particular chapter, and then any doubts are there, you leave in the columns without any hesitation. Okay, thank you.